Something is out there right now. No light, no sound, no warning. Just pure gravitational death moving through the universe. If it ever turns toward us, every ocean, every city, every human being who ever lived gets erased, not destroyed, consumed forever. Today, we go through exactly what happens, and the further you watch, the worse it gets. Somewhere deep in the Milky Way, roughly 100,000 light-years wide, there are an estimated 100 million stellar mass black holes drifting through the galaxy. Most of them formed when massive stars collapsed. Many of them have no host system, no orbit, no destination. They are rogue wanderers, moving silently through space at tens of kilometers per second. Now imagine one of them is heading toward us. At first, nothing. No alarm, no flash of light. A black hole emits no radiation on its own. It gives off no glow. It is, by definition, invisible. The only way to detect one approaching is by watching the stars behind it. They bend and distort as the black hole's gravity warps the space-time around it. This effect is called gravitational lensing. But by the time astronomers notice the distortion and calculate the trajectory, there may not be enough time to do anything about it. Let's say this black hole has a mass equal to 10 of our suns. That is relatively small in black hole terms, but it is 10 times the mass of the most powerful thing in our solar system. And it is coming. It enters the Oort cloud, the vast shell of icy debris that sits at the outermost boundary of our solar system, roughly 1 to 2 light-years from the Sun. Nothing dramatic happens here yet, but the gravitational disturbance begins. Billions of comets that have sat in stable, frozen orbits for 4 billion years suddenly get nudged. Trajectories shift. Some comets begin falling inward toward the Sun. Others get ejected entirely into interstellar space. The clock has started. The black hole crosses into the realm of the outer planets. Neptune, Uranus, Saturn, Jupiter. These are gas giants, massive worlds that have shaped the entire structure of our solar system for billions of years. And now, something more massive than all of them combined is altering the gravitational landscape. Here's where things start breaking down. Jupiter, the giant that has long acted as a shield for the inner planets, intercepting comets and asteroids that might otherwise hit Earth, begins to shift. Its orbit wobbles. The delicate gravitational balance that has kept our solar system stable since its formation begins to unravel. Planetary scientists have a term for this: orbital instability. And the simulations are terrifying. When one large mass enters a multi-planet system, the gravitational interactions become chaotic. Planets can be ejected entirely from the solar system. Orbits that took billions of years to settle into. Stable patterns can destabilize within decades, or even years, depending on how close the black hole passes. Meanwhile, those comets knocked loose from the Oort cloud, they're already on their way in. A rain of comets, far more intense than anything Earth has ever experienced, begins heading toward the inner solar system. This alone, before the black hole gets anywhere near Earth, could be an extinction-level event. Massive impacts, dust clouds, nuclear winters that last for centuries. But we're not even at the worst part yet. As the black hole moves deeper into our solar system, the Sun itself begins to react. Not because the Sun is weak, but because gravity doesn't care how powerful you are. It cares about mass. And this object is 10 solar masses pressing against the fabric of spacetime. The Sun's orbit shifts. It begins to move. Our entire star, the 8-minute light, provider of all energy on Earth, wobbles away from its position at the center of our solar system. And because Earth orbits the Sun, Earth follows. But Earth doesn't follow perfectly. The gravitational pull from the black hole tugs at Earth differently than it tugs at the Sun. This differential pull is called tidal force. Tidal forces are what make black holes so uniquely terrifying at close range. You've heard of tidal forces from the Moon. They cause our ocean tides. The Moon's gravity pulls slightly harder on the side of Earth, facing it than on the far side. The difference in pull stretches the oceans. Now scale that up to a black hole. 10 solar masses. The difference in gravitational pull across Earth's diameter would be catastrophic. The side of Earth facing the black hole would be pulled far more powerfully than the far side. The planet would begin to stretch. Geologically, literally, tectonic. Plates would be ripped apart. Earthquakes of magnitudes never recorded in human history. would tear across every continent simultaneously. Volcanoes would erupt globally. As the mantle gets deformed by forces, it was never built to resist. And we haven't even talked about the atmosphere yet. As the black hole draws closer, if its trajectory is a direct approach, the tidal forces grow exponentially. The atmosphere, that thin layer of gas clinging to Earth's surface that makes all life possible, begins to respond to the gravitational gradient. The side facing the black hole experiences stronger pull. Air pressure changes. Winds unlike anything in recorded history begin to move, not caused by weather, not caused by temperature, but caused by raw gravitational distortion. The oceans behave like the moon's tidal effect, but amplified beyond imagination. Tides no longer rise and fall in predictable cycles. They rise and don't come back. Entire coastal regions are swallowed by walls of water hundreds of meters, high as the ocean gets, pulled across the planet toward the black hole's side. If you are alive at this moment, and somehow watching this unfold, you would not be watching it for long. The atmosphere begins to strip away, not all at once, but enough. The side of Earth being pulled toward the black hole begins losing air into space. The magnetosphere, Earth's invisible protective shield against solar radiation, collapses as the planet's core gets deformed. Radiation floods in, and then, at a certain threshold distance, something called the Roche limit is crossed. This is the distance at which tidal forces exceed the gravitational self-cohesion of an object. In plain terms, this is the point where Earth can no longer hold itself together. The planet doesn't explode. It doesn't burn. It begins to disintegrate. Rock, water, atmosphere, everything pulled apart in a spiraling stream of debris that wraps around the black hole in a glowing disk, called an accretion disk. In the final moments of Earth's existence, it would be glowing, heated by friction and compression as its matter spirals inward, radiating X-rays, visible across the galaxy, a brief, brilliant signal that something once lived here. And then, silence. The black hole moves on, slightly more massive, carrying within its event horizon the compressed remnants of everything that ever existed on Earth. There is something deeply profound about thinking through this scenario. Not terrifying in a paralyzing way, but profound. Every single thing you value exists because of an extraordinarily precise arrangement of cosmic conditions. The sun at exactly the right distance, the moon stabilizing Earth's axial tilt, Jupiter deflecting incoming threats, the magnetosphere shielding life from radiation, the galaxy's quiet neighborhood giving us billions of years of stability. Remove one variable, and the chain breaks. A black hole entering our solar system isn't just a destruction event. It's a reminder of how improbable life is, how rare stability is in a universe that is, at its most fundamental level, governed by forces that owe nothing to our survival. We exist in a window, a gravitational window, a thermal window, a temporal window, and one day, whether by black hole, expanding sun, asteroid, or something we haven't imagined yet, that window will close. The question is not whether. The question is what we do with the time inside it. That is the story the universe is always telling. We just have to be paying attention to hear it.